Okay, hello everyone. In a new video. In this one we're gonna review everything related to electricity, mainly DC voltage resistors, electric power and energy AC voltage, and the voltage of the means for grade 9 students. Then let me start directly with the DC voltage. Let me split the board as the following. Okay, so remember that the DC voltage source, then this is the symbol of the DC voltage source. This is the positive pole and this is the negative pole. Then UPN is gonna be positive and UNP is gonna be negative. So some examples of a DC voltage source is the battery or the dry cell. Now we're gonna discuss the main electric components of a simple electric circuit. Then let me discuss the electric switch. And the electric switch acts in two different modes, the open and the closed. So the open doesn't allow electric current, so no current. And so the open switch doesn't allow electric current to pass through. And what about the closed switch? So the voltage across the closed switch is 0 since it acts as a connecting wire. Then this is a 0 voltage. Okay, now we need to discuss different laws of voltages and laws of currents. And let me classify the laws according to the grouping of the component. Then let me start by the series grouping. And the series, we know that the components are connected like this. So in this case, the current is the same, so same current. And this is known as the law of uniqueness of currents. And what about the voltage? The voltage is additive. So law of addition of voltages. Okay. Now regarding the parallel, now it's the same voltage, and this is the law of uniqueness of voltages. And what about the current? The current is additive. And then this is the law of addition of currents. Then remember that in series, the current is the same, and this is given by the law of uniqueness of currents. And the voltage is additive, we apply the law of addition of voltages, okay? And regarding the parallel connection, the voltage is the same, and this is law as the law of uniqueness of voltages. Well, while as the current is additive, because the current is gonna split like this, okay? So I is gonna be equal to I1 plus I2. Okay, so usually we need to say to mention whether it's parallel, and we need to measure the law. Okay, so remember that usually they give it half a mark for mentioning the type of the grouping. Now we need to mention the voltmeter and the ammeter. So let me split also the board like this. So the voltmeter used to measure the voltage, and it's connected in parallel. Okay, while the ammeter, it's used to measure the current, and it's connected in series. Now the voltage across the ammeter is 0. Since it is of negligible resistance. Okay, and now if the COM terminal, so remember that the COM terminal is related to the positive or negative reading. If the COM terminal is connected to the negative pole, then the reading is gonna be positive. If the COM terminal is connected to the positive pole, then the reading is gonna be negative. And now let's move to the oscilloscope. So this is the screen of the oscilloscope. So remember that this is given by 10 divisions and this is given by 8 divisions, but the importance of this can appear in the AC voltage. Now, if the luminous line is displaced upward, then the measured voltage is positive. Whereas if the luminous line is displaced downward, then the measured voltage is gonna be negative. It has two terminals. This is the phase and this is the mass. So this is the ground. Sorry, this is the channel. And this is the ground. So if this is the point A and this is the point B, then the oscilloscope is gonna measure you AB. And if this is the point C, for example, and this is the point D, the oscilloscope is gonna measure you CD. And the formula that is used to measure the voltage of the oscilloscope is given by U is equal to SV multiplied by Y. So this is gonna be expressed in volts, this is gonna be volts per division, and this is gonna be in division. And the triangle corresponding for this formula is given by U, SV, and this is Y. Now the final thing that we can add in this chapter is the indication of the components. Now suppose that we have the lamp L that carries the following indications, which is, for example, 3 volts and 0.5 amperes. Then remember that 3 volts is the rated voltage, and we should complete the statement under which the lamp functions normally. And what about 0.5 amperes? This is the rated current under which the lamp functions normally. Then we should complete the statement as we know. And we can add something related to the identical components. So if the components are identical, then they're gonna have the same voltage and the same current. Now let's move to a new topic, which is a new chapter, which is the resistors. Now the famous law is given by Ohm's law, which is given by U is equal to R multiplied by I. This is in volts, this is in ohms, and this is in amperes. And the corresponding triangle is given by U, R, and I. So for example, if we cover R, then R is gonna be U divided by I. And if we cover I, then I is gonna be U divided by R. Now remember the role of the resistor. So recall that the role of the resistor is to limit the flow of electric current in order to let other components to function normally, and it converts electric energy into thermal energy, which is known also as heat, and this effect is given by Joules effect. Okay, now we can discuss equivalent resistance. Now we have two cases, series and parallel. For the series is given by R equivalent is equal to R1 plus R2, which is the usual sum, whereas for the parallel is given by the reciprocal sum. Then let me give you an example regarding the parallel grouping. So they are connected like this. And let's suppose that this is R1, which is equal to 20 ohms, and this is R2, which is equal to 30 ohms. Then 1 over R equivalent is equal to 1 over R1 plus 1 over R2, which is equal to 1 over 20 plus 1 over 30. Here you need to take into consideration that you are adding two fractions. You need to take into, so you need to do the common denominator thing, or just put them on the calculator. It's gonna be 1 over 12. Then in this case, recall that 1 over R equivalent is gonna be 1 over 12. So now if you cross multiply, then R equivalent is gonna be 12 ohms, okay? Now remember that there is an instrument that can directly measure the resistance, and this is given by the ohm meter. Let me do another splitting. Now we need to discuss the shape of the characteristic current voltage curve. Now this is I and this is U. This is the shape of the curve, and if it's a straight line passing through the origin, it's gonna be a resistor. Then the shape is a straight line passing through the origin. Alright, this is known as the characteristic current voltage curve. Alright, and to calculate the resistance using the characteristic current voltage curve, either you can do the slope method, which is given by R is equal to UA minus UB divided by IA minus IB, by choosing 2 points. This is the point A and this is the point B, or you can do it directly by applying Ohm's law to any point chosen here. So you're gonna say that R is equal to U divided by I. You're gonna take this current and this voltage, and you're gonna do, for example, 12 divided by 0.1, which is equal to 120 ohms. Now here also I need to mention the conversions. Let me say that in order to convert from milliamps to amps, we divide by 1000, and in order to convert from kilovolts to volts, we multiply by 1000. Now it's rarely to happen that we have the following conversions, which is from kilo ohms into ohms, we need to multiply by 1000. And by that, I hope that we have reviewed everything related to DC voltage and resistors. Now we are ready to discuss the power, the electric power. So let me say that this is a new title. I'm gonna highlight the titles that we have here. So this is the first one. Oops. This is the second one. This is the third one. So let me say that this is electric power and energy. Then the formula of the electric power is given by P is equal to U multiplied by I. So this is expressed in watts, this is expressed in volts, and this is expressed in amperes. So this is the formula. And its triangle is given by, here because we have multiplied, and P is gonna be at the top, U and I at the bottom. Then for example, U is gonna be given by P divided by I, and I is gonna be given by P divided by U. Now we're gonna introduce an important quantity, which is given by the energy P times T. Now the SI units are given by joules, power in watts, and time in seconds, but usually we're gonna use the commercial unit, which is kilowatt hour. Now, so before I discuss the energy, let me discuss the two other forms of power related to Joules effect. Now let me say that the power also, in addition to P is equal to U multiplied by I, we have that P is equal to Ri square and P equals to U square over R. And let's recall that in order to use this and this, we need to prove them. So let's recall, for example, proving P is equal to Ri square, P equal to U multiplied by I. Now we're gonna use Ohm's law, which is U is equal to Ri, which is Ohm's law. Then we're gonna replace U here, and this is gonna be Ri multiplied by I, and this is equal to Ri square. Now, for example, if we want to prove that P is equal to U square over R, we can say U times I. Now, instead of I, we're gonna use that I is equal to U over R. This is given by Ohm's law. Plugging this here, this is gonna be U multiplied by U divided by R, which is equal to U square over R. Okay, now we are ready to introduce the electric energy, which is equal to E is equal to P multiplied by T. This is given by joules, this is given by watts, and this is given by seconds. But usually we're gonna use the commercial unit, which is kilowatt hour. And this is in kilowatts, and this is in hours. And recall that in order to convert from kilowatts to watts, we need from watts to kilowatts, we need to divide by 1000. Here, if you want to convert from kilovolts to volts, you multiply by 1000. From kilo ohms to ohms, you multiply by 1000. However, if you want to convert from watt to kilowatt, we're gonna divide by 1000. And now here we are interested in determining the electric bill, which is step 1. We convert power into kilowatt. Now in step 2, we're gonna calculate the energy E for 1 day. And step 3, we're gonna calculate E for a month. And step 4, we're gonna calculate the cost, which is equal to E multiplied by the price. And basically this is everything related to the electric power and energy. For example, I can mention something related to the advantage or disadvantage of Joules effect. So we know that the Joules effect is the transformation of electric energy into thermal energy, and this process usually happens in an electric circuit. So it is an advantage whenever we make use of the heat energy, and it is a disadvantage whenever we cannot eliminate this thermal energy, or we don't use this thermal energy. Now we're gonna move to a new topic, which is the AC voltage, which is a new chapter. Now, regarding the AC voltage, we can visualize the voltage of an AC source that has the following symbol on the screen of the oscilloscope, and on the screen we're gonna observe something like this. Okay. Now, using the screen of the oscilloscope, we can determine the values of X and Y. So recall that before we solve an exercise, we need to determine the values of X and Y. Then how would we determine the values of X and Y? Then let's recall here, for example, let's determine the values of X and Y. Then the value of X is determined from peak to peak. If you consider this document, so the value of X is given by then 1, 2, 3, 4, then X is equal to 4 divisions. And X can be counted from the center. We choose a point, skip a point, choose another point, then it's gonna be 1, 2, 3, 4. Then X can be counted either from peak to peak or from the center. We choose a point, skip a point, choose another point. Now, in order to determine the value of Y, the Y is from the center to the maximum point reached by the curve. Remember that each subdivision is 0.2. So this is from the center 1, 2, 3. Then this peak is pointing between 3 and 3.2. So this is given by 3.2 divisions. Now let's count X and Y for all of these documents. Then if we consider this one from peak to peak, now here from peak to peak, you see this is 1, 2, 3, 4. This one with this one gonna form 5, so X is equal to 5 divisions. Now if you find that it's difficult to count from peak to peak, we can count from the center. We choose a point, skip a point, choose another point, so 1, 2, 3, 4, 5, then X is given by 5 divisions. Okay. Now if you want to count Y, which is the number of divisions from the center to the maximum point, this is gonna be 1, 2, 3, because this is exactly here on 3. Then Y is gonna be 3 divisions. Now what about this one? We can count from peak to peak. So the number of divisions is gonna be 1, 2, 3, 4. Then X is gonna be 4 divisions. Now what about the value of Y? Y is gonna be greater than 2. Now if you can notice here that this is exactly at 2.4 divisions, alright? Now regarding this one, here we cannot use the method of 2 consecutive peaks because because we don't have two consecutive peaks, we need to count from the center. So we're gonna choose a point, skip a point, choose another point, and it's gonna be 1 2 3 4 5 6 7 8. The next is gonna be 8 divisions. Now this is the value of x. If you want to count the value of y, then y in this case is gonna be 1 2 3, then y is equal to 3 divisions. Now regarding this document, now if we choose two consecutive peaks, it's gonna be 1 2 3 4, then x is equal to 4 divisions. Now regarding the value of y, it's gonna be 1 2 3, then y is gonna be 3 divisions. Alright, now regarding this document, here we don't have two consecutive peaks, so we're gonna choose a point, skip a point, choose another point, and it's gonna be 1 2 3 4 5 6 7 8 9 10, then x is gonna be 10 divisions. Now regarding the value of y is gonna be from the center to the maximum point reached by the curve. But here, if you notice carefully, this curve here doesn't sweeps the third division, however it sweeps 3.2, and this can be done by considering a horizontal ruler and checking the peak, which coincides actually with 3.2. okay, but now currently with the new sessions, they are making this to be clear. So if you notice that this difference is barely seen or noticed, so don't worry about this. Alright, now after we have reviewed how to determine the values of x and y, now also related to this, we have given the vertical sensitivity and the SH. The SH, this is known as VB, so this is usually given in the text or given like this. If it's given like this, remember that this is the vertical scale, which is given by, for example, here 100 volts per division, and this is the horizontal scale SH or VB, which is given by 2 milliseconds per division. Remember that millisecond is not the SI unit of time. In order to convert from milliseconds to seconds, we divide by 1000, and this is gonna be 2 divided by 1000, which is equal to 0.002 seconds per division. Alright, or for example here, this is SH, which is equal to 5 milliseconds per division. So this is gonna be 0.005 seconds per division. Now, after we have at our disposal the values of x, y, SV, and SH or VB, now we can define several physical quantities. Now the period is gonna be SH multiplied by x, which is the time required for the voltage to switch on and off. And we can construct a triangle for this one. Let me say that the triangle associated with this formula is given by that this is the period, this is SH, and this is X. Now the second formula associated with the frequency is that associated with the period. Now let me say that the period, this is in seconds, this is in seconds per division, and this is in divisions. And let me complete them here. Now after we have determined the period, we can determine the frequency. The frequency is given by 1 over the period. Now this is 1, this is f, this is t, this is in hertz, and this is in seconds. The time, so the frequency is the number of cycles in, so the number of times the voltage switch on and off in 1 second. Alright, now associated also with x and y, SV, and SH, we can define the maximum voltage, which is given by SV multiplied by y. So this is the maximum voltage, and the triangle associated with this is given by UM, SV, and Y. Now for example, you can determine SV, then SV is given by UM divided by Y. Now what are the SI units? This is in voltage, this is in volts per division, and this is in divisions. Alright, now associated with UM, we can define something called the U effective, which is the voltage that makes the effect, which is given by UM divided by radical 2. Now this is in volts, this is in volts, and the triangle associated with this form is given by U effective, and this is UM, and this is radical 2. So for example, in this case, UM is given by U effective multiplied by radical 2. Now, and one common question about the type of voltage, it is AC sinusoidal. So whenever the shape is something like this is gonna be AC sinusoidal. And what is the justification in this case? Because since it is alternately positive and negative and varies with time, and the shape is sinusoidal, then it is an AC sinusoidal voltage source. So remember that this they usually give it half a mark, and this they give it, so, and the justification they give it half a mark. Now I want to mention something else. Now suppose for some reason we have that the maximum voltage is given by 15 volts and the effective voltage is given by 10.6 volts, and we have a lamp. Now you can check that if you divide 15 by radical 2, it's gonna be 10.6, and you have a lamp carrying the following indication, which is 15 volts, and they are discussing the functioning of the lamp. So we know that in order to discuss the functioning of the lamp, we need to compare the applied voltage to the rated voltage, but here in this case the applied voltage is given by the effective voltage and not the maximum voltage, because it is the one that makes the effect. Even if you connect a voltmeter to the AC source, it's gonna measure the effective voltage because it is the voltage that's gonna make the effect. So always whenever they are asking about the voltage, always consider the effective voltage and the AC voltage, because it is the one that makes the effect. And this is it for the AC voltage. Now we're gonna discuss the voltage of the mains, which is basically the last thing. Now remember that electricity of Lebanon now has a properties of 220 volts. It is an AC voltage source and of frequency 50 Hertz. So one should memorize the properties of the voltage of the Lebanon, electricity of Lebanon, which is 220 volts. It is AC sinusoidal and of 50 Hertz. Okay, so any component connected to the voltage of the mains must agree with these inscriptions. Now the volt outlet consists of two types, either 3 terminals or 2 terminals. The one that consists of 3 terminals consists of the live, the ground, and the terminal and the neutral, whereas this one only consists of the live and the neutral. So the live terminal, it is the one responsible for the variation in the voltage and for the electrocution. Now it can be distinguished using the live main indicator. Or the screwdriver tester. Alright. Now we are interested in the parallel connection, so or in the domestic installation. So in the domestic installation they are connected in parallel, and this is because to function independently. So whenever they are connected in parallel, they ask us why they are connected in parallel, and the reason it's given by to function independently. Then why they have the same voltage? So because they are connected in parallel, and this is given by the law of uniqueness of voltages. Now after we know that they are connected in parallel, then in order to determine the main current, then the main current in this case can be done using the law of addition of currents. And it's given by I main equals to I1 plus I2 plus etc. So this depends on the number of electric components that are connected to the domestic installation, and also the total electric power can be determined by P1 plus P2 plus etc. And this depends also on the number of electric components connected to each other. And in this case, the total electric power and the main current are related by the following formula. Then P total equals to U effective multiplied by the main current. And for sure, for this formula, we can construct a triangle. Now, in this case, we are interested in determining the main current. The main current can be determined by two ways, either from the law of addition of currents or by determining the total electric power. Then we're gonna use that I main is gonna be P total divided by U effective. Now, after doing so, we can choose the circuit breaker. So what is the circuit breaker? The most convenient circuit breaker is the one having, so let me say, is the one having rated current slightly greater than the main current. So for example, if the main current is set to be, say for example 21 amperes, and we have three choices given by 15, 20, 22 amperes and 25 amperes, we're gonna choose 22 amperes because it is the closest and the greatest, so it should be greater. Now the final thing that I should add here regarding the fuse, so let me say that the fuse is an electric component that cuts the circuit similar to the circuit breaker, but the fuse is usually used in small circuits like the DC voltage, and the fuse, whenever its switches off or burns out, should be replaced. It cannot be switched on again, and the voltage of the fuse is 0 because it is of negligible resistance. Now, what is the difference between the fuse and the resistor? The resistor is used to let other components function normally, where the fuse is installed in order to protect the circuit from overload and current. Alright? So basically, I hope in this video I have covered everything related to electricity for grade 9 students. So see you soon in a new one.